In this video, I'm going to be evaluating a function for a given input value or value for x. So if I had found, for example, g of 1, I would replace this x with 1 and this x with 1. And it's actually quite simple to do that. It turns out to be a little more challenging because we're plugging in a fraction, and that's the main reason why things tend to take more effort. So let's go ahead and plug in 3/4 for x. And I want to simplify this expression here. It's going to take a little bit of work. So let's first of all deal with 4 minus 3/4 squared. Now 3/4 squared is just 3/4 times 3/4. And when you multiply fractions, you multiply across, and so we're going to get 9/16. Now there's a couple of ways I could show you to do this, and you could also use your calculator. If you watch the video on the TI-84, I show you how to work with fractions. But the key is you need to get a fraction answer in order to end up with the answer that you're going to get in my math lab here. So one way I can do this is I'm going to write 4 as 3 plus, but instead of putting a 1 here, I'm going to write 16 over 16. So 3 plus 16 over 16 is still 4. The reason why I used 16 over 16 is because I'm going to subtract 9/16, and I needed a common denominator. And so now I can combine these together. I end up with 3 and 7/16. 16 minus 9, and remember the denominator stays the same. Now, excuse me, this can be written as an improper fraction, and that's how we'll need to write it to do the arithmetic that we need to do. So we just multiply 3 times 16, which is 48, plus 7, we're going to get 55 over 16. Now remember, it was the square root of this number, and so I'm going to go ahead and put a square root here. And anytime you have a fraction under a radical, it's not considered to be simplified. So let's get this simplified. We can write this as the square root of 55 over the square root of 16. This is how we divide radicals. This and this mean the same. And we know the square root of 16 is 4. So finally, we're ready to replace our denominator. This is going to be 3/4 over our denominator, which we simplified to the square root of 55 over 4. Now, this is a fraction, or fractions within fractions, but we can think of this fraction as a division problem. 3/4 divide the square root of 55 over 4. So let's go ahead and write it that way. And when we divide by a fraction, we can rewrite that as multiplication by the reciprocal. So it'd be 4 over the square root of 55. Notice our 4's cancel here. Now you could multiply across and then divide the numerator and denominator by 4. But this idea of canceling, we can cancel any factor in the numerator that you also have in the denominator. Basically, we're dividing by 4 and we get 1. So when we multiply across, we end up with 3 times 1, or 3, over 1 times square root of 55, which is just square root of 55. Now, this expression is actually not considered simplified because we have a radical in the denominator. Now, there was a time when we used to change this because dividing by a square root was very difficult before calculators came along. But I think these days this is called rationalizing the denominator. We're trying to write our answer so that everybody will end up getting an answer that looks the same. And so we want to make sure that we don't have any radicals in the denominator. So what we can do here is a little trick. multiply by the square root of 55, exactly what we have here. Now in order to make it legal, we have to multiply the numerator by the same thing. So basically we're multiplying our original fraction by something that's equal to 1. And so in the numerator we'll just get 3 times the square root of 55. Now in the denominator we just get 55. Now when you multiply square root of 55 times square root of 55, that's actually the square root of 55 squared. And I don't really need to multiply that out, because if you think about this, squaring and taking a square root are opposites. For example, if I gave you 5 and I said square it, you would get 25. And then if you take the square root of 25, you would get back to the 5. And so here, this is just going to be 55. And so this is our final answer, and that's it.